Hey everyone, and welcome back to AI Tech Talk channel. We're your source for, well, the latest scoop on tech news and modern methods. If you want to keep up in this crazy, fast digital world, you're definitely in the right place. I'm Aaron, your host.
And I'm Talia.
So today, we're doing a deep dive into something that's honestly everywhere right now.
Yeah.
Generative AI. More specifically, we want to unpack the techniques behind training these really powerful models. How do they actually learn? You've brought some great stuff for us to look at.
Absolutely. And, understanding the training, it's really key. It helps you grasp the potential, but also the limitations they still have. It's like looking behind the curtain, seeing how the magic trick works.
Okay, yeah, good analogy.
Okay.
So first things first, we hear this term constantly. Large language models, LLMs. Can you break that down? In simple terms, what are they? They seem to be the foundation for so much of this.
Right. So think of an LLM as a really complex machine learning model. It's been fed just an enormous amount of text data, like vast quantities. And that huge exposure lets it, well, not just understand human language, the quirks, the context, but also generate it. Generate text that sounds surprisingly human, creative even.
Enormous is probably an understatement. I can barely imagine how much text that is.
Yeah.
But it's not just about like dumping a digital library onto an AI and hoping for the best. Is it our sources talk about specific training techniques developers use? Could you give us a quick overview of those main strategies?
Exactly. It's more sophisticated than that. There are several main ways to refine these LLMs. One big one is prompt engineering. That's all about how you ask the question, essentially. Crafting the input prompt to get the output you want. Then there's fine-tuning. That's where you take a model that's already trained and train it more, but on a smaller, very specific set of data to make it an expert in, say, medical language or legal documents. And finally, RG. That stands for Retrieval-Augmented Generation. It's a really interesting approach that mixes the pre-trained model's knowledge with the ability to look up fresh information from outside sources in real time. Each has its own, pros and cons.
Okay, let's zoom in on prompt engineering first. It sounds like it's all about the interaction, the conversation with the AI. What's the core idea?
Yeah, fundamentally, it's about the input. How you phrase your request, the prompt massively influences the AI's answer. A good prompt guides the model. It gives context, states the goal clearly, maybe even sets some rules for the response.
So what's the appeal?
Yeah.
Why is this a go-to technique? What are the upsides?
Well, a big one is speed. It's fast to implement. You don't have to retrain the whole model, which takes time, and frankly, a lot of computing power. You can just start trying things out. And a well-written prompt can pack in a lot of information, guiding the AI effectively. Plus, it's adaptable. You tweak the prompt, you get a different result. Easy to iterate.
Seems pretty efficient.
Yeah.
But are there drawbacks? Where does prompt engineering maybe hit a wall?
Oh, definitely. It often takes some fiddling, trial and error to find the perfect wording for your prompt. You might not nail it on the first go. And for really complex stuff, things that need knowledge way beyond its initial training data, just prompting might not cut it. The model's still working primarily from what it already knows, just guided by you.
Right. Our sources mentioned a few specific techniques here, like zero-shot and few-shot prompting. Can you maybe give us a quick rundown of some of these common ones?
Sure. Zero shot is interesting. You basically ask the model to do something it wasn't explicitly trained for. Like, ask it to summarize an article on a super niche topic it never saw in training. It just uses its general language skills. Few shot is a bit different. You give it examples right in the prompt, like, translate English to French. Sea otter sera, loutre de mer. Cheese. It sees the pattern.
Ah, okay. Teaching by example within the question itself.
Exactly. Then there's chain of thought. This is cool for reasoning problems. You tell the model to think step by step. It then writes out its reasoning process, which often leads to better answers for complex logic tasks and lets you see how it got there.
That transparency seems useful.
Very. Then you've got role prompting, telling the AI to act like someone specific. You are a sarcastic pirate.
Oh, okay.
Prompt chaining breaks big tasks into smaller, linked prompts. Program-aided language models let the AI write and run code as part of its thinking. And tool use prompting guides the model to use external tools, like a calculator or a search engine.
Wow, okay. It's amazing how much influence we have just by phrasing things carefully. Let's switch gears to ARI Retrieval-Augmented Generation. You said this one lets the AI look things up. How does that work?
Precisely. ARI basically supercharges a language model by letting it fetch relevant info from outside in real time. So it's not just stuck with the knowledge it was trained on, which can get outdated. It can access much more current information.
And how does it do that? What are the components?
Two main parts. First, the retriever. Its job is to take your query and search external sources, documents, databases, maybe parts of the web. It finds the most relevant snippets of information using methods like, keyword matching or sometimes more advanced semantic search that understands meaning.
So it's like a built-in search engine for the AI.
Kind of, yeah. Then second, there's the generator. This is usually a standard LLM, like we discussed. It takes your original question plus the information the retriever dug up, and it combines them to generate the final answer, making it contextually relevant and informed by that fresh data.
So the AI does its homework before answering. That sounds huge for getting up-to-date, accurate info. What are the other big advantages of Argy?
Well, cost is one. You're not constantly retraining the massive base model with every new piece of information, which is computationally expensive. And like you said, access to real-time data is a game changer. Responses are more current, more reliable, especially for topics changing quickly. It also broadens the scope. The AI can answer questions about very specific or niche things not covered well in its original training.
Okay, that sounds powerful, but
Right.
what's the catch? What are the challenges or downsides with Ragu?
Well, a key thing is its dependency on those external data sources.
Ah, makes sense.
If the information it retrieves is wrong or biased or just low quality, then the final answer the AI generates will likely be flawed too. Garbage in, garbage out, as they say.
Right, even if the AI itself is smart.
Exactly. And also, getting the retriever and the generator to work together smoothly and efficiently, that can be technically tricky to set up and maintain.
Okay, that's logical. Dependency and integration complexity. Now, the third technique, fine-tuning. You compared this to specialized training earlier. Can you elaborate on how that works for AI?
Yeah, the analogy holds up pretty well, I think. With fine-tuning, you start with a model that's already pre-trained on general language data, and there's a lot about language structure, grammar, basic facts, etc. Then you train it again, but this time on a much smaller, carefully selected data set that's laser-focused on a specific task or domain, like medical diagnoses or legal contract analysis. This extra training makes the model significantly better, more accurate within that specific niche.
Our source material had a neat little graphic for this. Original data plus new specific data leads to a fine-tuned AI model. Simple but clear. So the key benefit is specialization, accuracy in a field.
Exactly. Improved performance on those target tasks is the main goal. It learns the specific jargon, the nuances, the common patterns within that field much better than the general model could. Think about medical terminology or legal precedents. A fine-tuned model can grasp that specialized context.
Got it. So why not just fine-tune everything? What are the limitations or costs?
Well, first, you need that specialized data set, and it has to be high quality and labeled, usually. Creating that data set can be a huge effort, time-consuming, expensive.
The data bottleneck.
Precisely. Second, the fine-tuning process itself still requires significant computing power and time, though maybe less than initial pre-training. And third, there's a potential trade-off. A model heavily fine-tuned for one very specific thing might actually become less good at general conversation or tasks outside its specialty. It can lose some flexibility.
So he becomes a specialist, but maybe not a great generalist anymore.
Kinda, yeah. It's a trade-off you have to consider based on the application.
Okay, this is great. We've covered prompt engineering, RGA, and fine-tuning. To really nail the differences, especially between RGA and fine-tuning, one source used a chef analogy. I found that really helpful. Could you walk us through that?
Oh yeah, that's a good one. It really clarifies things. So RA is compared to a chef who always looks up recipes. This chef doesn't need to have everything memorized. Someone orders beef Wellington, they pull out the cookbook or check an app. They can make almost anything, provided they have access to a good recipe.
Okay, versatile, but dependent on the recipe source.
Exactly. If the recipe is flawed, the dish might be too. That's like RA relying on external data quality.
Makes perfect sense.
Yeah.
And how does the fine-tuning chef compare?
The fine-tuning chef is like someone who's spent years mastering, say, just Italian pasta dishes. They've practiced relentlessly, internalized countless variations of doughs, sauces, techniques. They can whip up amazing pasta quickly, consistently, without looking at anything. It's all ingrained knowledge.
Deep expertise.
Deep expertise. But ask that pasta master to make sushi.
They'd be lost.
Probably. They haven't been trained for it. Their specialization limits their breadth outside that core skill. That's like fine-tuning. Great depth in one area, but maybe less flexible overall.
That really crystallizes it. RA, broad access, relies on external info quality, fine-tuning, deep skill, high performance in a niche, but less flexible outside it.
You got it. And deciding which to use, or maybe even a combination, depends entirely on what you need the AI to do, what resources you have, and what kind of performance you're aiming for.
This has been super insightful, a really great deep dive into how these generative AI models actually learn. You've made some pretty complex ideas feel much clearer. Thanks so much for breaking it all down.
My pleasure. It's a fascinating area, isn't it? Constantly changing, too. Always something new to learn about how these things work.
Absolutely. Well, that just about wraps up our deep dive for today here on AI Tech Talk channel. We really hope this chat gave you a clearer picture of the methods humming away behind the scenes of generative AI. It's pretty amazing stuff. Maybe next time you're interacting with one of these tools, you'll have a little more insight into, what's making it tick.
Definitely. Understanding the basics of training really helps put both the cool capabilities and the current limitations into perspective.
Thanks again, everyone, for tuning in. We look forward to having you back next time for more explorations in the world of tech. Until then, goodbye
Yes,
for now.
3, 1.